I want to say thank you all for coming. Maybe this is a bit of an obscure topic for most of you, but for me, it's kind of my everyday obsession. So hopefully I can convey why I think this topic is so important, primarily because we have a rapidly changing industry and we're kind of stuck with whatever we build for several decades. So it's good to be attentive and get ahead of the curve. Building science is kind of a hot topic these days on some of the publications like Fine Home Building and Journal of Light Construction. So you probably see more of this if you look around for it. Whoopsie, I don't know how to change slides. Here we go. Okay, so my name is Ashley and I'm a licensed mechanical engineer. And I feel like this is a fairly accurate description or portrayal of me. I certainly know my way around a job site. I spent the last 5 years in residential design build, but my first love and my current practice is in engineering and building science consulting. So that's kind of my basic introduction. I was writing this presentation and I realized that it's actually kind of like 3 full masterclass level presentations that I was trying to cram into about 30 minutes. So before I just whip you through my slides, this is kind of what I plan to talk about. So I wanted to focus on the building science and all the envelope practices, but I realized it's really important for us to care why the hell we should be doing any of these envelope upgrades, or why it even matters, especially in our temperate climate. And what I'll say is that it has a much greater system level effect than simply saving energy. So I'm going to start with kind of the carrot of why we should care. And on the flip side of that, I want to talk about kind of like the stick of what can go wrong if we're not being attentive to our envelope design and construction details. And then finally, I'll get into all the building science and practices. So, all right, so I want to start with some definitions. I want to start with a drink of soda. Okay. So I'm going to use these words envelope, enclosure, building shell over and over again and interchangeably. And it's basically, I'm just talking about what separates the inside from the outside. And I say the word assembly very often, and this is basically all the materials that we stack together to make up the walls or the roof or the floor. So there's many ways to do energy efficient design. And I just wanted to specify that the type of design I'm talking about for high performance envelope is one where we're just exercising a really high degree of control over what's going through the envelope, and particularly thermal control and air control, and also intentional ventilation. A thermal bridge, I kind of say this often without thinking much about it, but it's basically anything that interrupts the insulation that is not insulation itself. So it's a way for heat to go around the insulation. And then passive house itself is just a voluntary, really strict energy performance standard, but the means and methods or the principles of passive house to achieve that standard is kind of the gold standard of the high performance envelopes that we're talking about. Okay, so in a nutshell, we're talking about building homes that are much more like this thermos than the glass coffee pot that we need to plug into the wall to keep it hot all day long. And that is that is the relevant piece, is the plugging into the wall. to keep it hot. So, so when we're considering why this even matters, especially in our temperate climate, really this is a story about our electricity grid and our grid security. I don't know if any of you have kind of the same sense of the frailty of our electricity grid these days, and you know, kind of like what can go wrong. So taking a look at what's happening right now, you know, we're quickly moving into a renewable energy future, and we have great market penetration of solar energy. It's required on new homes, all of that. I think it's a good move. We need to keep moving in that direction. But now we have to deal with this intermittency between, you know, there's fluctuations of times that it's generating and times that it is not generating. So now we have this mismatch between when we're creating the electricity and when we're actually using it. So, oopsie. Moving forward with the system, kind of like the new challenge is to get these two to align better. So the ways that I know how to do that, you know, we can just keep burning fossil fuel. We can add a bunch of batteries, other thermal energy storage, or we can kind of tinker with the demand side and try to just line it up better with the time that the electricity is available. So there's kind of like a bunch of technologies being developed to do that. And I think this is kind of the assumed future of what our grid's going to look like, where we have renewables, and then we have some battery storage, and then we have demand side. So the thing I really want to call into question is this idea that we're just going to slap a bunch of batteries all over everything and make up the difference and, you know, call it good and not have to change anything we're doing on the actual infrastructure and the building side. So, you know, I don't know if you've looked at the, I guess the scorecard for batteries and their environmental impact, geopolitical, all of that. So it behooves us to look at ways to avoid as much of these batteries as possible. Obviously, we can't completely get around it, but the more we can do low tech, the better. So this is what I'm proposing as the reason why our, you know, building our homes a lot more like a thermos really matters. You know, I myself have deeply questioned whether it makes sense to put all this extra bulking of our materials into the homes themselves. And, you know, I really see that the thermos effect opens the path forward for this energy security. So, and this is the only thing I know of that really addresses both the daily mismatch and also the seasonal. So I want to just take a really quick look at how that works. So this is kind of like the daily solar generation curve. Obviously, in the middle of the day is when we have the most generation. And even in the summer right now, when we have ample availability of this energy, we're still kind of miss the mark with the time that we're trying to turn our air conditioning systems on. So from like a central power plant perspective, this is what we're asking these turbines to do, where in the middle of the day, there's really not a lot of demand from the central plant and from that equipment. But at the in the evening, when everybody gets home and they want to flip all their appliances on, that's when we need the turbines to just like get up and running at the drop of a hat, and it physically doesn't work that way. So this is causing all these like rolling blackouts and all sorts of problems, even in the summer. And so if we look at how a passive house functions, this is an example. In New York in the winter, it's like 20 degrees outside, and we can go 5 days of not turning the heat on, and we're still, you know, in the mid 60s. So it's got this passive survivability aspect. And basically, you know, you can do your heating and cooling electricity chores during the day when you have this availability of electricity. Same story for the summer. There's no cooling in this building, and we've got these fluctuations of temperatures outside in the 90s. And then, yeah, I want to talk about the seasonal mismatch as well. I think net zero energy has kind of been the pinnacle design goal for a while. And the problem with that is that we're assuming that the grid is going to be a battery that can store extra from the summer and put it into the winter demand. And actually, there's not really a good technology that actually does that well. Any technology that holds energy for multiple seasons has just a lot of losses. And so the only way to really address that winter criteria is to reduce kind of the peak or the peakiness above the base load and just try to get it as flat and consistent as possible. So, you know, the envelopes are really drastically reducing those winter heating demands, which is the important thing. So after all that, you know, what does this take to accomplish in the Bay Area? We're basically talking about doing really good air sealing and wrapping the house in a couple inches of continuous insulation, and then making sure we have insulation under the floor as well, which is obviously not typical unless it's, you know, a radiant heating building. All right, let me take a pause really quick. Okay, so again, the benefit is we've got much tighter control over what's being lost, you know, the heat being lost through this building. This is kind of a quintessential passive house picture where you can see all the other buildings in the winter lose their heat right through the walls, and the passive house doesn't. But by the same token, now we have this consequence that we don't have heat driving through the walls. And so we don't have this benefit of being able to dry things out as easy. So this brings me to my next topic, which is this confluence between energy performance and, I would say, like the biological health of the building. Obviously, viral health is a big topic these days, but what I'm talking about is keeping our buildings dry. And so I've really had my finger on the health and wellness industry for a while, and particularly for people with like chronic illness, chronic inflammation, all these kind of mystery afflictions. And I have been seeing and hearing many health practitioners pointing their fingers at tight buildings and energy efficient buildings as the problem. And the reason for this is because now they're saying, you know, we have this increased concentration of exposure getting trapped inside of the buildings, and we're inside our buildings all day long. So at the same time, the passive house community is aggressively marketing as a more healthy alternative to traditional construction and even code built homes. So I guess there's kind of like, from what it looks like, there's a paradox here, but what I'm actually seeing is, you know, from one side, we're increasing the requirements by the energy codes, but we weren't doing the same with our mechanical ventilation requirements. So passive houses are always mechanically ventilated. So that's one difference. And the other thing I see is that passive house is already very attentive to the envelope detailing and just tends to have a much higher success with water management and building science. So the thing The thing that I would like to see more of is just this open and honest conversation, especially by the passive house community, that, you know, to admit that shit happens and things do go wrong. And I want more passive house and high performance home people to just openly discuss, you know, how tolerant are these energy efficient designs to anything going wrong? How easily can we fix them? I think there's a real growth edge for our industry on that topic. So how have I learned all of this? Unfortunately, I've been through my own chronic illness and experience with chronic inflammation and all sorts of problems. So I kind of went down all the rabbit holes on behalf of all the rest of us, and with a lot of trust issues and, you know, questioning everything. And, you know, I won't say too much about it, but as professionals, you know, we don't want to be responsible for making people sick. So, you know, unfortunately, I think we're in this position where we kind of don't have a choice whether we learn how to do this well or not, because we've got these energy codes nipping at our heels. We're not going back to energy hog buildings, and the onus is on us to really take on this burden. And I think the task is really to make sure we're including good ventilation in our projects. Any modern project should have good ventilation, and you know, just be educated on water management and good water management practices. So again, I think, you know, we've been harping on energy performance for decades now, and I want to just do this like slight shift towards how to keep our buildings healthy, how to keep our buildings dry. And I think the energy piece just really kind of falls in line after that, or, you know, along with it. So let me do a little time check. Okay, I think I'm doing okay. So we made it to the building science section, and by virtue of everything I just said, I think you'll understand why my main focus in this section is more on water management, moisture dynamics. Bulk water management is the number one. Good ventilation practices is in there. And then really the energy performance piece, all it boils down to is having continuity of our thermal insulation, having continuity of our air control. So yeah, so I think the thermal or the energy piece just kind of happens naturally. Okay, let me take a pause real quick. So I think a lot of the problems happen in our industry with water damage and moisture control because we don't have this distinction. I learned through Christine Williamson, and I stole her slides. She's kind of one of my building science superheroes. So distinguishing that there are actually 3 different ways to manage water in our building assemblies. And so we make mistakes because we don't understand how they work. And most of the time, what people in the industry think we're doing is completely excluding water from penetrating the materials at all, when this actually only really works for things like curtain walls. It's not very common, mostly because the outer cladding just sees so much abuse in its service that it just can't be relied upon most of the time for water exclusion. We call it the intrusion, exclusion, delusion. The second way is for us to use masonry type materials that don't care if they get wet. They can absorb a whole bunch of water and then dry out later. I actually think there's a whole bunch of problems, and not necessarily healthy type of buildings, or it's tricky to get a healthy building that is a masonry building. This could be an entire class in and of itself, but that is the intent of how they work is they can absorb a lot of water and then dry out later. And here's the Marin Builders Association. So this is what we're accustomed to building most of our homes and buildings, light frame construction or stick built. And the nature of this type of building is that we are using moisture sensitive materials. And then we use this whole system of components that work together to protect those materials from getting wet and getting damaged. So kind of the dirty secret about this whole system of water management is that the materials are in fact getting wet, and they're getting wet often. But the key is that we're kind of always maintaining this equilibrium where they're not getting wet for long enough to get damaged. So there's like the two levers that we're pulling of increasing how much drying we're doing and reducing the amount of wetting. So now we've just decreased the amount of drying we're doing with heat blasting through the walls, and we need to work on other ways of enhancing drying and reducing wetting. So how do materials get damaged? It depends on the material, but basically for that specific material, if it spends enough time within a certain moisture content, then we'll have biological conditions growing. So this system of components is protecting our materials, and you know, again, this is a direction that I think we want to move in as an industry. We want to use more natural materials. We want to use recycled materials, and these are exactly the ones that are the most sensitive to moisture, and including our fast growth lumber. So it helps to understand how water can penetrate the assembly and get and wet these materials. We basically have a source of water, a driving force, which is one of these, and then a path for that driving force to push the water through. So the system of cladding plus a weather resistive barrier with a little gap, and then air sealing is they all work together in this way. So the gap between the cladding and the drainage plane is just where all the action happens, and this is where we have the most control over how to enhance the drying, because that is where we're draining the water. That's where we get convective drying. We have a capillary break, and we also have a place for the vapor pressure to release. And now the air sealing is important because otherwise the wind-driven rain, you can see in the upper right-hand corner, you know, if the wind can still push things against gravity and up and over, you know, a back dam behind a window, for instance. So putting that air seal in is important to just arrest that driving force. These are kind of the standard of care that is recommended these days. So rain screens are pretty popular. Head flashing on any horizontal junction. And again, just making sure you have that little gap between the WRB and the cladding. Windows are the place where you're going to see the most damage and have the most risk. So again, the assumption is that water will get in there. Make sure the rough opening is protected. always leave the bottom nail fin open. Don't seal that because that is the place where the water needs to drain out. And then you can see in the lower right-hand corner, so from the outside, you want to seal the sides and the top, and then create that baffle effect. And then from the inside, you seal all 4 sides for that air seal so that you stop any wind-driven rain. Okay, air control. I'm going to try to wrap up in just a minute here. So the common phrase is that buildings need to breathe. And I think this is the biggest pet peeve of all building science folk, mostly because it's fairly imprecise and not very accurate. So what they really mean is we want outside air for breathing. Of course, that's true. We want ventilation. And we also want things to dry out. So if we pick this apart a little more, from a vapor permeability perspective, yes, the practice is to just not trap moisture. That could be, again, a whole discussion for another day. Air actually carries a lot more water than vapor trappings or the risk of trapping moisture. So it's more important that we're controlling air, and we don't want it to just come into the building or into the wall wherever it wants to. We want to do that through the ventilation system. This gives you an idea of kind of like the volumes we're talking about. So yeah, we've already reduced our air leakage by like 75% just from our standard modern building practice. And so this is kind of what the design recommendations are for mechanical ventilation systems. I know Alex is going to talk more about why we think this isn't even quite enough for a ventilation system, but that just kind of gives you an idea of like the scale of things. And the ventilation strategies. So as far as I know, the only thing that's really required these days is to just have bathroom exhaust fans and kitchen exhaust fans. So that basically means you only get one side of this picture, and the makeup air is coming through your crawl space and through your sheetrock and carrying all the stuff with it. So the standard of care, and I actually think like the biggest room for improvement in our home construction these days is, and especially from a manufacturer perspective, like I've shopped around for heat recovery ventilators, balanced heat recovery systems, and there's like one manufacturer who does really high quality stuff, and everybody else is really lagging behind. So I'd like to see a lot better practices of installing these systems and doing it really well, because again, this is now like the new lungs of the house, and we're like fully relying on this system to be clean and well maintained, well installed, and operating well. So I think I'm running out of time a little bit, but okay, so here's the guts of a heat recovery ventilator. This is not the top of the line unit that I mentioned, but it's I would say maybe the second in line, which is not necessarily comparable. And I think I've said all I want to say about that. A quick note about why everybody's talking about continuous exterior insulation. Basically, when we add insulation, everything on the outside becomes closer to the outdoor temperature. So if it's cold enough outside, you could have condensation happening on your sheathing. So the idea is to just keep the sheathing on the warm side. And that's basically explains that. And then quick note about thermal bridges. So thermal bridges, again, are anything cutting through the insulation. And the thing to know about them is that they just have a much larger impact than your logic brain will ever think that they actually do. So that is why they're important to pay attention to. It's a non-linear relationship. And even things like windows are very important to have a good thermal performance. All right, so kind of here to wrap up, I think as building industry professionals, we really have a lot of power in just doing these practices to impact the many facets of our community through building local assets, building our own energy security, empowering our trades, all of that. So that's kind of my pitch. And I would love to continue the conversation with anybody interested. I can talk about this all day long. And again, I just wanted to thank you for giving me a stage to talk about this. I would say this time last year was a pretty low point in my life, and I was very sick, and I was really questioning myself and my capabilities. And after everything that I've healed and everything I've learned and all these rabbit holes I've gone down, I just have never had more conviction about how important this really is. So thank you so much, and I can't wait to hear Alex and Jen.
Thank you. Good job, Ashley. That was a great summary. Can people hear me? I'm getting some nods. This is going to be a little bit more popcorny, trying to kind of drive home some of the points that Ashley just made about the fear factor of why we need to think about high performance building envelopes. So feel free to turn on your mics and maybe respond to a few of these. This is an old DuPont ad. And good things are twice as good in cellophane. And a lot of people fear that a lot of the new buildings or retrofits that are occurring are essentially just wrapping the building in an unbreathable plastic. And you wouldn't want to put your kids in a plastic bag. So why do it for your multi-million-dollar home? And just kind of as a general guiding philosophy, health drives a lot of our business. And boy, as Ashley just alluded to, when your health is impacted or the health of someone you love, kind of everything else doesn't matter. So there's a few kind of key things you can do within a building to ensure kind of long-term health benefits. Ashley mentions these heat recovery ventilators and energy or enthalpy recovery ventilators. Everybody should know these. You should be using them on all projects. There's one feeding my office now. They're severely underutilized for the amount of impact and benefit that they provide to our indoor environments. This is proven time and time again. We've done lots of studies with these, having them on for a week, off for a week. You can measure carbon dioxide, which just skyrockets really quickly with 2 people in a bedroom with the door closed, compared to running a heat recovery ventilator. Similarly, doing studies after new construction, you can track VOCs and all the aldehydes. And the one thing that really makes a difference, you either have to have all the doors and windows open and some auxiliary fans running, or you can have the energy efficient, thermally comfort, constant balanced ventilation solution that these provide. So if you're not using them already, please check them out. Little discussion about filtration and some of the benefits. I mean, the particulate filtration, we really advocate media filters. A lot of the HVAC subs out there are advocating these electrostatic filters. They were sold en masse to schools across the country during COVID. In my opinion, we would strongly recommend leaning more towards a traditional media filter. MERV 11 is great if you can get it. MERV 8 is also helpful. But it's not going to do anything if your return air plenum looks like this, full of dog food and hair. And this is really common. When you go into existing buildings and start to investigate, you'll find this in return air plenums. Once you show it to people who have been suffering from asthma for a decade, a little light bulb goes off, but it's amazing how many people are suffering and are unaware of it. Why? This is another return air plenum just full of dirt. This happens to be a solid metal duct, which could be thoroughly cleaned. Most of the flex ducts that you see cannot, unfortunately. Or know where your return air is coming in. If it's being pulled in from a mechanical closet or your dirty garage, it's another, or out by your car where you might idle. That's another common source of indoor air pollution. So just in quick summary for ventilation forced air, good duct design and insulation are critical. In general, we recommend a media type filtration. And for our target ventilation standards, we're doubling ASHRAE minimums. That really makes a difference. And it's one of the few, there's only a few things where the energy discussion kind of bumps head to head with air quality. This is one. So there is a slight energy penalty for increasing your ventilation. The only way to do it effectively and stay within energy code requirements is with good heat recovery or energy recovery systems. And it's hard to be a building. Like, this is hard work. We don't live just outside without clothes on for a reason. Like, it's a lot of work. The sun and UV takes its toll. Wind takes its toll, as we have all been feeling the last week. Water is persistent and really difficult to keep out over time. Insulation, we're all well aware of. And where all of these materials meet is a common place where you have different expansion, contraction, and a common place for there to be building failures in your envelope. So some leaks are kind of obvious. This is due to improper flashing above a roof. But fortunately, as you can see, the husband fixed this one. But some leaks, when you see it like this, it's really obvious, it's catastrophic. We all kind of know it. I can't hear anybody else. I don't know if everybody's turned off or not, but when you see something this dramatic, it's almost always a top-down water leak. So good flashing details around the chimney probably would have helped this. Good periodic inspections on the roof to identify, issues above would have prevented this. Let's see. This is another one. Now this was the bottom up. This is a flood that occurred. And when it's just rampant everywhere, in this particular picture, you can't see any kind of shadowing of framing or identify one particular area that's worse than another. When it's really just everywhere, and you see this microbial growth so extensive, it's usually a mass flood event that's occurred. Oh, now besides excellent taste in music or video games, what happened in this person's room? So can you see my, again, I still can't hear people, but if you can you see my cursor? Can you see the cursor?
That looks like a pipe, thermal bridge.
Yeah, and so here you see the thermal bridging or kind of shadowing. Does this not kind of look like the inverse of a thermal image? And so the thermal bridging, either framing or a pipe in this corner, there's obviously no insulation. In this corner, no insulation. And so there's just a little chat going on earlier about why you might get mold in an older building in a closet. Ventilation, poor insulation, and excess indoor humidity causes something like that. So what Ashley was mentioning about the continuous exterior insulation would probably help. Similarly, with some better interior ventilation. And again, just kind of a reminder of what that might look like. This is kind of an interesting reverse image of that. So you can see the shadowing of framing, only it's in the reverse. And where the studs are, there's like less microbial growth. So can you guess why that might have been? This was in a garage where they were storing a boat in the winter. And the thermal bridging that was occurring had a benefit in this scenario because it was drying out or having less likely of condensation on all of the thermal bridge joints of the framing. So you can get that shadowing effect either way. And I guess in this case, thermal bridging, and the heat loss from indoors was actually a benefit. Just while we're talking about water and moisture management issues, these flume monitors are so easy to install. They're subsidized by our water districts. I look at this digital thing and connect it with the Wi-Fi. I think there's no way it's going to talk to this analog meter in the ground. Plop it on there, and sure enough, within a day, identified like 8 to 12 ounces of loss that was occurring over the period of a day. Doesn't sound like much, but if it's happening in every home in Marin, it's actually a pretty big deal. So then dropped those little blue tablets in the toilet tank, found 2 toilets that were leaking, fixed those, and lo and behold, just through this little monitor, we're able to save a lot of water over the course of a year. Similarly, that flume thing might have been able to prevent this, because these people had a busted pipe in the kitchen plumbing that was left unattended for 4 to 5 months in a vacation home. And they came back and it's basically a total loss. So some sort of monitoring or leak detection system, or at least better consideration for kind of your worst case scenarios, can help people a lot and avoid something like this. Also, if you're not in your vacation home for 6 months, anything in your home warranty is void, and in your home insurance. They almost all have a clause in there about requiring kind of weekly visits. So by the time it gets this far, it's a total loss and it's all on your shoulders. It's worth having somebody swing by and check on the building. I'm going to skip these. We don't have a lot of extra time. This is the inside of somebody's basement to illustrate worst case scenario with static pressure from the exterior. So they did not have good drainage along the outside. And they will now. It can be very expensive. I mean, if this was just dealt with originally, and previous building codes didn't have any requirements for waterproofing the foundation or having better drainage and French drains around the foundation. So sure, this is a reality, but boy, those problems, they're expensive to fix. So if you're ever doing new projects, try to do them right in the first place. Thermal imaging can really be helpful to identify leaks, both outside. The left is a membrane roof with water beneath certain portions of it. The right is a drywall ceiling where you couldn't quite see any leaks yet, but there was a leak from above. Thermal imaging will quickly help you identify those areas. This is just an example, kind of focusing back on the envelope, that this hole in existing siding, it's only like 5-year-old siding, pushed in that little divot there, and water actually came out. This is above a window, a 3-story building in San Francisco. Started peeling off the siding, and you just realize how extensive the problem. There are multiple waterproofing problems with this building, including the flashing around windows and doors, lapping of the WRB, and not having any drainage plan behind the siding, all things that Ashley's spoken about. This turns into a complete residing job.
Hey, Alex, I don't want to interrupt you, but probably like a 1-minute warning so we give time.
Okay, thank you. They dig deeper and it just, water can really do tons of damage. And we've all seen this. It happens on many buildings. It does seem to happen and be more catastrophic with newer building materials. And so that's the case in this building. So quick summary there, just pay attention to your waterproofing details, material compatibility. Continuous insulation when you can do it is fantastic. And plan for how these assemblies will dry. If water eventually will get in. If caulk is your last line of defense, water is going to get in there. And there are a lot of assemblies where people say, oh, the caulk's going to keep water out. Well, it might for a few years, but not forever. And once water gets in there, if you don't have a plan, it's going to be really expensive. That's all. Thank you.
Yay, thank you so much, Alex. That was awesome.
And I'll round things out. Just have a couple, it looks like we have very few minutes left, and I do want to leave a couple of minutes for questions if people have burning questions that they want to ask any of us. But my name's Jen Green. I'm a customer programs manager at MCE, which actually started in Marin. but we do serve Contra Costa, Solano, and Napa counties. And so if you live in Marin, we are your default electricity provider. And there should be a line item on your PG&E bill that says MCE is your electricity provider. So happy to be part of this discussion today. Just to briefly, I thought I would talk about some of the programs that we have that have been designed to take into consideration all of the concepts that were previously discussed just now. I, for one, just want to say that after seeing all of those slides, I want to go outside and like take huge gulps of fresh air, because all of the mold and spores is just like causing an asthma attack. I don't even have asthma. But anyway, on point. We do have a number of programs. I encourage everybody, since we don't have a lot of time, to email me afterwards at jgreen@mcecleanenergy.org if you have any particular questions. But just want to go over one program in particular. Our home energy savings program is focusing in Marin this year, mainly towards the second half of the year. And what that program does is offer incentives to homeowners to choose their own contractor to do upgrades to their home that focus on sealing the envelope correctly, and also providing insulation for ductwork and also attic spaces. And we do provide some incentives for ventilation as well as electrification measures. So looking at, when you seal up a home, what are you left with if you have a lot of combustible appliances or combustion-based appliances, like your furnace, your stove, your water heater? You're causing a lot of indoor air quality problems. So we do offer incentives that cover 100% of the cost for these envelope and duct sealing and insulation and electrification measures. It is limited right now to moderate income customers. So we're making a big effort to upgrade over 60 homes in Marin, which doesn't sound like a lot, but if you think about the population of Marin and the moderate income level, we're going to attack a lot, or we're going to address a lot of the home's problems. We also looked at some of the funding streams do not allow for us to provide incentives for things like electric panel upgrades, ventilation, like the previous speakers were talking about. So we do have additional funds that will cover 100% of electric panel upgrades should homeowners be interested in getting like a heat pump water heater, heat pump HVAC, or even, we don't provide incentives for induction cooktops, but that's in the works this year. We also have incentive programs that are available for multifamily properties. So if you work with multifamily properties, we cover about 80% of EE and electrification upgrades for folks that qualify. We also, I want to point out one other program that we have, which is for contractors. It's electrification and energy efficiency and building performance training, coupled with free matching of a contractor with folks that are interested in learning and available to join your team and work on electrification and energy efficiency upgrades. So if you're looking for new staff, we have this kind of try before you buy option for contractors. We pay up to 160 hours for somebody to check out working for your company and for you to check out these job seekers. And then we have a lot of job skills training for those folks as well. And we have ride-alongs for contractors. So if you don't know how to install a heat pump water heater, we'll train you on how to do that. It's all free. So get in touch with me. We're really short on time, but get in touch with me if you're interested in contractor training, matching with job seekers. If you want to know more about our incentive programs, I'm available. And I'll turn it over to Q&A.
Thanks so much, Jen. That was amazing. Very exciting programs too. And does anybody have any burning questions?
Jen, maybe you could put your contact information in the chat.
Yeah, because so anyone who wants to save our contact information, we'll put it in the chat, and you can save the chat through the, I think it's 3 dots on the bottom, and then click save chat. So I don't know if Alex has got this. Sorry, is there any questions? We have like 1 minute, 2 minutes. Everything was perfectly clear. Or we could.
Is there a mass unmute option you can do? I can't hear anybody.
Nicole.
Hi, I have lots of questions. So I'll just ask one that's more personal, which is personal to me, sorry. 2x4 construction, how do you possibly make that into a passive house?
Exterior insulation and airtightness, basically. So again, the best place for some of the insulation is to go outside of the sheathing, because we want to keep the sheathing on the warm side of the wall. So as we're bulking up our thermal performance up in our climate zone, because it doesn't get all that cold outside, I think it's recommended at least 10% of the total R value should be outside of the sheathing. But if you're working with 2x4 walls and you just want to have better energy performance, that's how you would do it. And it's not for the faint of heart in terms of effort, because all of a sudden now you have to extend all of your window and door openings, any hose bibs going through, everything needs to come out a couple of inches. So it's certainly an effort, but that is the only way that I know.
Yeah, because I have no insulation whatsoever.
Oh yeah. And Graham Irwin just put in a link to the Midori house. They did one of the first passive houses in California, I believe. Okay, we're at 1 o'clock. I'm assuming nobody else has any burning questions, but just wanted to thank you again. I don't know, Rick, do you want to say the bidding farewell?
Yeah, just want to thank everybody. Those are great presentations, a ton to learn there, a lot that obviously realizing that there's so much more I don't know than I do. And this was great. And great. Thank you for leaving your contact information too. Alex, if you can put yours in the chat. This will be recorded. We'll put this up on our YouTube channel for those of your colleagues that didn't get a chance to join us today. And again, on behalf of the Marin Builders Association, thank you.
Thank you. Thank you all. Go get some lunch.
Yeah. Okay. Ciao. Bye.
Thank you, everybody. That was awesome.